Welcome to Programming Redux. Last time I talked about functions. Today I will talk about the programming paradigm behind Redux. So far I have presented bits and pieces of Redux. I have sort of discussed the language from the ground up. Now it's time to talk about the core language, its form and function. There are many programming paradigms to choose from. Perhaps the most notable programming paradigms are imperative, declarative, functional, and symbolic programming paradigms. Because of historical reasons, I choose to stick with the imperative programming paradigm. If you take some of the well-known imperative programming languages and plot them against a few desired properties, you get the following graph. The first thing that you notice about this graph is that some of the desired properties end up being at the opposite ends of the spectrum. Basically, this means that there is no perfect programming language and that there never will be one. So, where is Redux in this graph and how should it be positioned? To answer that, let me first show some examples that have guided my decisions. Let's start with simplicity. As an example, to print hello world in Java, you need to type in this code. There is quite a bit of extra stuff there to get the work done. In comparison, the corresponding program in BASIC looks like this. Clearly, one of these is simpler than the other. Let's then think about expressivity. Suppose you would like to store string values in a stack and push a new value like Niklas into the stack. Then this is the program that does it in BASIC. In short, you have to manage the stack by yourself. The corresponding program in Java looks like this. Clearly, one of the languages is more expressive than the other. As for plasticity, consider the following basic program summing array values in a pointwise manner. You really need to read and interpret the whole code to understand what is going on. In C++, the same can be expressed with a single program line, provided that suitable operator overloadings exist for the objects. Again, one of the languages is more flexible than the other. However, this is not the full story. The problem with operator overloading is that the programmer needs to keep track on the operators and their meanings in varying contexts. Of course, the compiler knows which operator applies and where, but this might not match with what the programmer had in mind. Because of this, plasticity is not that important to my mind. Then about the learning curve. For instance, C++ is such a multidimensional programming language that there is an abundance of books for it. Here are just some of them. By the way, none of these books cover all the aspects of C++. In contrast, here is the entire language of Dartmouth Basic. I think I prefer the short learning curve. So, to get back to the graph, I aim at an imperative programming language that is simpler than BASIC, but almost as expressive as Pascal. Redux may even have less plasticity than BASIC, but its learning curve will then also be shorter. So, all in all, I aim at a language that is simple, clean and easy. I suppose the big question is it possible to design a programming language that is easy to use but still useful? I think it is, but it comes with a cost. For instance, you cannot assume that Redux could be used to program something complex. After all, that would go against the simplicity requirement. Still, I think Redux will be useful for many things.